Are we in for a treat, everyone? We have saved the best for last. Our trailblazer talker is Dan Mapes, and I'm just going to say a little bit about Dan. He has written he's the co-author of the seminal book, The Spatial Web, which is about to come out in China, published by Tsinghua University, one of the most, if not the most prestigious publishers in China. It's the Harvard University of China. He truly is someone who looks at future science fiction and turns it into science reality. I believe, and many others, that he is the Leonardo da Vinci of our era. So I think it is only appropriate, and I'm totally embarrassing him, but it's all true. I think it is totally appropriate that we end our Trailblazer talks with Dan Mapes, who will be sharing more about the spatial web and so much more. And we're here. Take it away, Dan. Thank you so much.
Good afternoon, everybody, and thanks for virtually coming today. A couple of my heroes are here. Paul Debevec, he and I have been friends for 20 years, and I'm a big fan of his work. And Ted is on my advisory board. So a couple of real serious, significant inputs into my own way of thinking. Great to see you guys. So my name is Dan Mapes. I'm the founder of a company called Versus Labs here in Los Angeles. We create software that connects everything. We combine artificial intelligence, which really is the most extraordinary invention in history. We connect that with immersive media, AR, VR, and MR, and other things coming, and with blockchain technologies into a single unified system that can work over the global network that some people have historically called the metaverse. Science fiction writers call it the metaverse. We call it the spatial web. And I'll tell you why in a little bit as it unfolds. We've only got about 20 minutes here. So I'm going to kind of do a quick summary of the spatial web, why it's important for our future. And our website, though, is loaded with lots of info, and you can follow up on that as well. So this is an amazing moment to have this online conference. We're presenting online today because it's too dangerous for us to actually meet in person. And for large groups, it will be for some time to come. So it's really driving us toward these new medias. Even though we're currently still using video conferencing, it's really what we're using today, and a lot of people are doing Zoom calls and Google calls and things like that all over the world, we can see the day coming when we're going to all start to meet in shared immersive environments. Immersive media will be common in our future work, study, play, socializing, and gatherings like this show us the potential of working together online. So we're just going to do more and more of that. Things are never going to go back to the way they were. We've done a giant behavior change on the planet. Everybody all over the globe is now using online media and working together and talking together and socializing together. We're not going to go back from that. So there's 5 things that are driving us toward what we call the spatial web, which is to have this immersive environment full time. One of them is working online is a great way to work. And now we're learning about it. I'm not having to get in my car, go to a meeting, jump on a jet, go to a meeting. We'll still do that, but probably a smaller percentage of the time than we've done before. Secondly, the internet has gotten faster and our chips have gotten faster. So we can do things online that we couldn't do before. When I first downloaded my first web pages back in 1994, so I mean, you had to wait while the page downloaded, and if you had more than a picture, a postage stamp size image on the page, it really clogged it up. Now we're watching Netflix on our smartphones, so the speeds are really going through the roof. Third, we have a generation that's grown up playing 3D video games, and they're comfortable in 3D spaces. They think this way. I mean, Minecraft is a huge game that kids are playing all over the world right now. And I think they've got 8 times the surface of the Earth now in Minecraft worlds. So it just shows you how much training we have in building virtual worlds, living in virtual worlds, playing in them. Fortnite has got millions of people showing up for Marshmallow concerts. I mean, over 300 million people now are members of Fortnite. So it's quite remarkable that we've got that level of training. Then the AR and VR headsets are becoming more affordable and capable. And then lastly, and I think this is something that the COVID-19 crisis has shown us, we want to manage our cities better. We want to be able to find face masks anywhere in the world. We want to manage our global health system more effectively. And personally, we want to create more immersive entertainment and other ways of socializing together. So these 5 things are real drivers toward something that you might call the metaverse or the spatial web, along with things like movies like Star Trek and Blade Runner and Ready Player One and everybody else, kind of teaming it up. We've seen it. We've never been able to make it. It's really, we've had this limitation. And the primary limitation is that our World Wide Web was designed for documents. It's an HTTP protocol, hypertext transfer protocol. So it's about transferring text across the network. It really doesn't handle these 3D worlds very well. And so our big computer games, so when we play them, they have to be downloaded. They're not just a website. And our cities, our smart cities, which we want to make smart, we can't really see them like this image in front of us, because they're siloed off into some special program. And even then, nothing is interoperable with anything else. So you're really kind of isolated into whatever you're looking at. Whereas the web is wonderful, because with Google indexing, I can just type in hotels in Fiji and immediately gives me all the websites in the world that are dealing with hotels in Fiji and ranks them in order of importance. So we want that now in 3D space as well, and we're going to get it. And so what we did, what Ted Shelowitz recommended, was go ahead and take on a huge Herculean task and attempt to do this. And now after 3 years, we've succeeded, and it's starting to spread around the world. Like I said, we wrote a book on it, which is available on Amazon, called The Spatial Web. It's now it's coming out next month in China, and then soon after that in Korea and Japan, and most everywhere else. It's going to be available in English. We'll probably do a Spanish version at some point. But one of the problems that the spatial web solves is that it opens up many new uses of the internet. So we're kind of used to the web as it is, but actually we'll see in the future that the current web that we have is only about 5 or 10% of the web that we're about to have, because we currently have an internet of information, but we're now about to have an internet of everything. All the people, all the places, all the things, and all their interactions and transactions will now be webized into something that, again, science fiction writers call the metaverse. We call the spatial web. So we're about to live in this, and we're going to have glasses and things like that we can use. So McKinsey, just to connect our IoT devices is an $11 trillion value. And right now they can't be connected because they're all on separate protocols and very isolated. You can build an application with IoT devices in your company or your factory or your farm, but it's not on the web. And the overall transformation, the way the World Economic Forum is seeing it, is a $100 trillion opportunity out there business-wise. So this is going to, once the doors open onto this new environment, this new metaverse, this new spatial web, we're going to have huge new business entrepreneurial opportunities that everybody on this line will be involved in, like it or not, because that's going to be where the action is. So let's face it, we're living in complex times right now. I mean, this is not the simple world that of the 1950s and 1960s. We got a climate crisis, income inequality, overpopulation, homelessness, financial crises, wars, and now a global pandemic. And it can look a bit hopeless at times. I mean, people get overwhelmed by it all. But as Darwin once said, it's not the strongest, it's not the most intelligent, it's the ones that adapt. And human beings are so adaptable, and technologists are so adaptable. And so this pandemic is exposing the limitations of our current global information system. We couldn't find anything. And it was impossible to coordinate activities between our cities, our states, federal government, and international organizations. But we know that the combination of AI and the spatial web will help us address many of these problems much more effectively than we're currently doing it. So as bad as things are at the moment, we're actually at the dawn of an entirely new era of computing. And that's going to use AI and blockchains and spatial webs in many exciting new ways that I can't even imagine yet. Some of you people online with us here today will be inventing the applications that shock us and completely transform education or completely transform healthcare. These are things that are going to happen pretty soon. So this new era is going to combine immersive media, artificial intelligence, blockchain technology is going to really make this period of time that we're living in right now will look like the Stone Age in 2050. We'll look back to it and it'll be more like looking back, not 25 years or 30 years, but maybe 60 or 70 years, because the pace of change is higher now than it's been. So when we think of let's see, what did I want to say here? Gamification. That's the other thing that comes along with this. Once you actually have a big spatial web, you can start to really look at things the way a game designer looks at things. When you look at like something like Fortnite or any of the big games, the game software knows where every asset is in that game. It knows exactly where they are. It knows all the players, both human and AI. It knows the rules of the game. It knows how far you've progressed in the game. If you've earned special points or assets, it automatically adds them to your inventory, and the game keeps track of all those accounts. You can query the game at any time, and there's detailed knowledge about how many players are in the game and what they're doing, what their status is. Imagine if we had that level of knowledge of our world. We wouldn't be having the problems we're having tracing down where ventilators might be for COVID-19. We would know where they all are. And we're actually working with some of the largest hospital groups in the world right now, here in the US and in Europe, for just this application. So that's about what's to happen. We're going to make some really huge changes. We're going to move online. We're going to work and play online. Robots and AI are going to change the nature of work. So it's just going to be a continuous unfolding over the next 25 to 30 years. As Ted says, really looking beyond 10 years out is really hard these days. But 2050 is kind of a nice time horizon. It's 30 years. It takes us back to 1990 till now. And so we look ahead to 2050. By that time, I mean, you can really see the nature of work will be really different. The nature of healthcare will be different. The nature of education will be completely different. We're going to give everybody on this planet, everybody, free of charge, a better than a Harvard level education by 2050. Everybody will have access to that because it'll be online and it'll be free. It'll be a public utility. And it'll be, because it's immersive and artificially intelligent and virtual worlds, it'll be a level of educational programming that we've never had, and it'll be self-paced and custom tailored to each individual. So we'll have 10-year-old girls doing PhD level work that now you would need to have an advanced degree to attack. So what's coming is something really, really exciting. And because of the pandemic, I think Ted mentioned there's some silver linings here. It's really forced us to learn to use these online technologies faster than we normally would have. So what might have happened in 10 years will probably happen in 5. What might have happened in 20 will happen in 8. So we're going to move more quickly now as this comes on. What else do we want to say here? So our company is creating key technologies that will help us create this new spatial web. These technologies have to do with interoperability and linking everything together. And again, if we look back at the World Wide Web, it really began with a web protocol that allowed documents to be linked together. But now we're moving from 2-dimensional documents to 3-dimensional spaces. And as we endow these spaces with intelligence, we have something called smart space. They're self-aware. Every space, whether it's a small space like a house or a large space like a city or even a country, the space knows everything that's going on within it.
Dan,
yeah.
Dan, I'm not sure that your slides are advancing. We see the gamification slide.
Yeah.
This happened to someone else, so maybe just double check.
That's good.
There you go.
The gamification slide is fine. I mean, it holds up pretty well. But yeah, so we're going into a lot of change, and we've done it before. Here we can see we've gone from the Stone Age to artificial intelligence in 100,000 quick years. And the pace of change is speeding up. So this is a pretty exciting time. But the reason I left the game slide up is because our world is already a game. We're already playing a game. Every day we make decisions. And scientists call that the study of game theory. And even in the depths of evolution, it's evolutionary game theory. So guess what? We've got some pretty cool new game players here. We've been really good at playing games, but we've got a new game player in town. And so in 1997, AI beat Garry Kasparov for the World Chess Championship. Nobody thought that would ever happen. No one could ever beat a great chess grandmaster. And that's 20-some years ago. Then in 2011, AI beat the Jeopardy champions. They said, okay, you can win at chess. It's kind of a mathematical game. You can never win at a game where you actually use the English languages and the nuances of it. Of course, it won that game in 2011. And then Go is an impossible game. No chance we could ever win at Go. Google's AlphaGo won the beat the World Go champion in 2017. And really, in coming soon, AI is going to help us really protect us from future pandemics. It's going to help us manage our cities. And humans and AI working together are going to really help us develop a smart world. It really is a partnership because we're going to co-evolve with the AIs. It isn't that the AIs are going to come in and just run away. We're going to get smarter too. As I said, we're going to have 10-year-old girls getting their PhD in computer science in probably 10 years or so. And that's actually going to happen a lot. So our intelligence is going to increase along with our partnership with the AIs. And the AI will operate at a person level all the way up to a planet level. So each of us will have personal digital assistants that can help us and solve a lot of problems and answer questions and handle a lot of the issues we deal with. Our cities will be managed them. And we're working with Yale right now on the Open Climate Project to apply the spatial web and artificial intelligence to keeping a better, tighter understanding of the carbon footprint on the planet. So all this together is going to help to create a smart world over the next 10, 20, 25 years or so. So the promise has been great with AI, but we felt it needed a new framework for it to be really effective. It needed to be aware of the world around it. And this is what Versus has created, a smart space linked to AIs that can turn the internet into a real-time planet-scale nervous system that enables AIs and humans to collaborate in the metaverse to manage our planet and our lives more effectively. So the next stage is the age of AI and the spatial web metaverse, and it can help us solve our problems. As our population currently is nearly 8 billion, but it's going to grow to 10 billion by 2050. So we're going to need better technologies. So that's the kind of look at it. There's smart spaces. Here's how we do it. Every computer game is an example of a smart space. What Versus has done is to enable any space in the world, from hotels to hospitals to cities, to become programmable smart spaces. These individual smart spaces then can be linked together to create a web of spaces, which we call the spatial web. Now the world can be programmed, automated, and verified with blockchains and other kinds of things like that in real time and in new ways. Very quickly, a hospital system of 10 hospitals can know where every empty bed is and what type it is, surgery, ICU, whatever, where every ventilator, every mask, anything like that. But to get this new capability, we had to create two separate pieces of software. And that was the reason nobody's tackled it until now. One piece is a new network protocol to replace HTTP, because hypertext transfer protocol is not going to let us manage our cities well. So we had to create a hyperspace transaction protocol, HSTP. And the problem with that is it takes a lot of time and energy, and you don't make any money from it, because we want to give the protocol away so that it becomes a global standard. I don't want to be driving down the street with or walking down the street with a pair of glasses on, and I can only see what's running on iOS, or I have to take those glasses off and put another pair of glasses on to see what's there in Android. No, if we're going to be dealing with a smart world that's got augmented reality information embedded into it, then we want to be able to have a unified global standard underneath it, just like we do with the World Wide Web. So to have a worldwide spatial web, we need a worldwide protocol. And that means it has to be put into a nonprofit foundation, just like the web, and given away for free. And so we've done that. That's called the Spatial Web Foundation. And then we built a new set of programmer tools to create applications for smart space. And that we run in a profit company, kind of like Salesforce or SAP. And there you can kind of see how we do it. So we have the Spatial Web Foundation and Versus Labs. One is like Linux, one is like Red Hat, one is open standards, the other's platforms, kind of like Salesforce or SAP. And this way, it kind of created a bigger problem to solve, because we had to build the foundation of the protocol first before we could build the application toolkits on top. But now we're working with IEEE and other standards bodies around the world. So we hope the HSTP standard will spread globally the way HTTP did. And then we can all build any applications on top we want, and anybody else can build application tools on top of HSTP, just like they do on top of HTTP, because it is an open standard. We don't control it at that point. It becomes a public utility. So with all that in place, we can kind of look at a few things that we're doing here. There's the spatial web. It's Web 3.0. We always have a data, a logic, and interface layer. In the last round, it was apps running in the cloud with mobile touch. In the new layer, it's AIs connected to blockchains with AR/VR interfaces. We have spatial domains instead of website domains. That way you can have a domain for a city, you can have a domain for a restaurant in the city, you can have subdomains all throughout large campuses or complexes or whatever. And these subdomains then provide rights and privileges on who can program what within those domains. The web is obviously going from 2D to 3D. And it's also going from symbolic to spatial. You can see what we've done in MAPES over the last 20 years, from text-based to map-based, and now we're going to embed right into the world. We also have a bunch of exponential technology, robotics and DLTs and mesh and data security tools and other kinds of things. They're not all talking to each other. So again, a standard protocol allows them to actually be linked all together. So what we've done is we've created a universally interoperable digital reality modeling language, kind of like HTML, but for spaces. And there's an example of it. This allows you then to program who can do what, where, and for how long. So here we've got a little example of a hospital robot. So the robot, by virtue of the authority of the Health and Human Services, can operate within the USC Medical Center and shall have the right to take blood pressure and so on and so forth, and for certain amounts of time and under various authorities. So you can kind of see with these reality modeling languages, we can actually start to program the world around us. And here you can kind of see the three layers there of who, what, and where, and what are the rules, and who's allowed to do what, and where are they allowed to do them. So these are overlays then that overlay the surface of our physical and our connectivity world, and link between the IoT devices and the cloud and everything to give us programmability at the core. And so that gives us then context in the world around us, a complete and coherent digital model of the world that accurately and holistically represents the social, semantic, and other rules that we want to play in this environment. So we call that context. And there's a quick look at our architecture. At the bottom is the protocol layer. In the middle is the platform layer that allows all these programs to develop. In the top left, you can see various kinds of applications that people can then build: logistics, health, education, smart cities, entertainment, that kind of thing. So the system is up and running now, and you can use it for practical things like designing buildings, or obviously really fun new entertainment applications. It gets rid of the problem we currently have, in that the world's kind of messy and complicated and big, and we try to fit it all into a spreadsheet, which is only probably about 10% of the data. Where we have the spatial web, we almost have what's called like a digital copy of the world. And so it's feeding us real-time data about what's actually going on physically in the world. So this mixture of the digital and physical is something that really comes together and really allows us to then start to see the city really with a digital overlay, or a warehouse, or a hospital, or other kinds of things. And so we have working versus health, we're working in climate, because really they're all the same problem, just with different interfaces. And obviously security is really a real key issue. When you have this level of awareness of everything that's going on, then you could have really huge privacy problems. But from the very, very beginning, this has been GDPR compliant with self-sovereign ID and zero knowledge proofs and other kinds of things built in for data privacy and security. Everybody owns their own data in the system. You're not logging into anything anymore, so there's no tracking you and tracing you. And we got a bunch of great strategic partners, everybody from NEC to IEEE to Intel, Esri, lots of great companies we're working with, and a great board. There's Ted and other great people, Peter Diamandis, other wonderful people on the board that are helping us. And obviously some great big markets, supply chain management, smart cities, hospitals, here's supply chain, all integrated now, so you can see every part of the supply chain. There's a fully integrated smart city that all the subsystems, which are now isolated, now can all be treated together as one full meta model. We've got all kinds of really cool interoperability tools. And ultimately, at the end of the day, we finally get to a smart world, maybe by 2040 or 2050, where we actually have a planetary nervous system that is really taking care of things and really meeting our SDG goals that the UN has articulated. We've written a book about it called The Spatial Web. I think you'll enjoy it. We had a blast writing it because really this has been a labor of love. It's been a passion. And,
hey, I'm okay. By any chance, do you know Don Mapes? He runs a company called Versus. Mapes, M-A-P-E-S, and he has a company called Versus.io doing like
Anyway, I wanted to thank you guys for listening in today. My 20 minutes here is up. And happily, Molly, if you've got anything you want to take it away from, but that's kind of a quick look forward from the spatial website.
Great. Yeah. And Robert, you might want to mute yourself. We can hear you. And I can tell you're excited about Dan's talk.
Good talk, Dan.
Thank you. Thank you.
Yeah, that was incredible. See what I mean? So for starters, I want to drill down on a couple of things we were talking about, the smart city and your hypertext language. Can you say a little bit more? People are curious about this language. How do they access it? How do they develop with it? Tell us more about it.
Yeah. No, it's great. So as you kind of saw there in the architecture section, the base layer is the protocols and the kind of the equivalent of a hypertext markup language. We call it a hyperspace modeling language. We'll publish all this stuff over the next, probably by June. Right now we're building things in beta, but we'll probably release the public-facing documents in June. And then we've got the COSM system sitting on top, which allows the applications to be developed. But anybody else can build a competitor to COSM if they see a better way of doing it, because underneath it all are the open protocols, so they're fully published, so everyone will have access to them. Once you've got that kind of a spatial modeling language, then you've kind of turned the world into something like a Unity game. And we've been working closely with Unity and with Esri. We're full partners with Esri. They're the #1 map company in the world. And most of the COVID maps you're looking at are running on Esri maps. But now we've linked in the spatial web with the Esri maps so that any augmented reality object can be placed accurately anywhere on any map. So then that starts to give us the ability then, as you can see, to overlay intelligent information into the city, and also to put IoT devices throughout the city, be able to get real-time readouts, almost like like you would on a human body. So a lot of this is biomimicry at the end of the day. We really are putting an autonomic nervous system onto the surface of the planet, and we can get real-time readouts on the health of the planet, health of our cities, health of our businesses, everything. And so that's kind of how that works at the smart city level.
Okay, we have time for one more question. Although there are more questions, maybe we can get them answered.
Yeah, and that's why I put my email up there. If you've got any questions, feel free to shoot it over. We got a good website as well at versus.io. Yeah, we're giving talks. We have the book, so we'd love to engage anybody in helping to bring this. It's obviously a collective action. One of the things I love about the spatial web, and let me just say a couple of moments about that, because as much as I love Second Life, and as much as I love Fortnite, and I think they're wonderful virtual worlds, they are still walled gardens. I have to go into their world and do things. Whereas the internet is a open, decentralized system where anybody can build a website any day of the week. And so we wanted to make the spatial web exactly like the World Wide Web, only for spaces. So anybody can build any space they want, any smart space, and link it to any other space. So then we can navigate through the spaces, and we've got central indices and everything, just like Google Index, so you can migrate around and find things and do the things you want to do. But again, in a fully decentralized fashion. That way, 1 billion people currently built the current websites. I think there's 4 billion websites right now. We'd like to see 1 billion people build the spatial web as well.
Dan, thank you so much. Boy, did that deliver. I mean, standing ovation, that was incredible. And it makes the world in the future. So we really appreciate you doing this Trailblazer talk today, and also for your tremendous support of this event. And with that said, we're going to transition right into the so I'm going to stop the recording. And again, we didn't get to all the questions, Dan, but I'll catch up with you and make sure we put them on the website. So for anyone who didn't get a question answered, don't worry. We will make sure we take care of you.
Thanks so much, Molly. It was really, really great to be here today, and again, to share the moment with Ted and Paul, a couple of my superheroes myself. So that was really awesome.